Hello there and welcome to this video. In this video, we're going to take a look at the different numeric data types that Rust makes available for us when we are declaring variables of the integer data type. So first of all, what's an integer? An integer is just a whole number that stands on its own without any fractional part. So if I have the number 3.142, it is not an integer because it has a whole number part, which is 3, and the 0.142, which is the fractional part, okay? So examples of integers are 1, 10,000, 2,500, any number that stands on its own. And Rust gives us several different integer data types that we can use. And as a programmer, you need to learn how to use the right data type for the right variables and the right purposes for that matter. So the first group of integer data types we call the signed integer data types. And we have the I8, I16, I32, I64, and even I128. So the I stands for integer, and the number that follows it stands for the number of bits that it can contain. So for example, I8 can take numbers that are made up of 8 bits. So from a binary number that has 8 zeros to a binary number that has 8 ones. So that is basically 0 to 255. And for the signed integers, it can store negative and positive numbers. So half of the bits are reserved for storing negative numbers and half of the bits are reserved for storing positive numbers. And we also have the I size, which is for storing pointer sizes. And pointers are things that we'll also be talking about in later videos. Now we also have the unsigned integers, which is U8, U16, U32. So for every signed integer data type, we also have the corresponding unsigned data type. Okay, so one more thing I need you to know is that by default, integers assume the I32 data type. So if you declare a variable like I showed you in the previous video, which is of the type integer, and you don't annotate it with a particular integer data type, then Rust is going to default it to I32 unless you specify otherwise. So let's see how to declare variables, integer variables, because now we know how to declare variables. So I'm going to say let number, and then I'm going to declare something that is I8, okay, and then I'm going to store in, let's say 200, and then I'm going to print ln, and I'm going to print my number. Let's just say num, and then I'm going to print num here. So what is the problem here? Let's hover over it and see. It says literal out of range. Why is it out of range? It is out of range because this is a signed 8-bit number, and because it is signed, half of the bits are reserved for storing negative numbers and half for positive numbers, and so this cannot store any number above 127. Okay, so let me go down here. In fact, let's compile and let's see what the compiler is going to tell us. It's not going to be too different from what the text editor is telling us, but look at a more useful information that is telling us. It says the literal 200 does not fit into the type I8, whose range is -128 to +127. So the biggest number we can store in an I8 is 127. The biggest positive number that we can store is 127, and the smallest negative number is -128. So I'm going to do cargo run, and now we don't have any issues, so it goes ahead to print it out for us. Okay, now let's change this to a U8, and you can see that because U is unsigned, it cannot take negative numbers. So let me try to store, let's say -1 in it, and this is also a problem because it is an unsigned data type, and so it cannot take integers. So when you read, you can get more information. It says it cannot apply unary operator negative to type U8. So basically, because of its data type, it cannot store negative numbers. However, because this is unsigned, all the bits are reserved for storing positive numbers, so I should be able to go all the way to 255. So you can see that by design, Rust is even preventing common programming errors known as overflows and underflows, where you are storing a value that is much bigger than the capability of the data type that you are choosing. Okay, so this is one way of using U8, and we have seen I8, but there are of course the different data types out there. And remember that it's default, Rust default integer data types to I32 if you don't specify anything. So if I come here and I don't specify anything, then the variable num is actually an I32, and nothing much is going to change in this code except that the data type or the variable num can store much bigger numbers. Now let's see how big of a data each of these types can store. Okay, so I'm going to just use print statement here. So I'm going to do print ln, and then I want to see the minimum that an I8 can take. I'll put the value here, and let's see the maximum that an I8 can also take. Let's put the value here, and the way we get that is you use the data type and then you call min, and then we are going to use the data type once more. Sorry, it should be small, so this, and we're going to call max on it. Okay, so let's compile this program and let's see the range of values that I8 can take. Sorry, so I wrote I8, but I used I32 here. So I'm going to change this to I8, and I'm going to change this also to I8. Okay, so let's run our program again. And you can see that an I8 can take a number as small as -128 and as big as 127. Why don't we go ahead and do this for the rest of the data types, the integer data types that we have. So I'm going to change this to I16. This is also going to be I16, and I'm going to change this to 16. I'm going to change this also to 16. So I'm going to pause the video and I'm going to copy and paste for all the different data types that we can continue from there. Alright, so I've gone ahead to insert code for getting the minimum and maximum values that each of these integer data types can help us to store. And so let's go ahead and do cargo run, and you can see that for I8, a minimum of -128 and the maximum 127, and this for 16, 32, I64, and I28, and we also have for the unsigned integers, so for U8 0 to 255, for U16 0 to 65535, and it follows in that same pattern. And you can attest that these are rather big values that can store almost any number that we want to use in our program. I think I pasted this twice here. So for U128, yes, U128, let's run it again so that we have the correct output here. And you can see that this number is a very huge number. I mean, count how many zeros can follow the 3, and this is a very big number that should help us to store any type of number, integer, in our programs. Okay, so two last things that I want us to look at before we end this video is to talk about another way that we can indicate the data type of an integer using a suffix. Okay, so if I come here and I say let's age is equal to, note that I am saying let's age and I'm omitting the type annotation. I'm not specifying which data type it is. Okay, but I can say 67 and I can say I32. So this automatically means that age is an I32 integer that is storing the value 67. This is not a style that I like very much, but it is something that people also use, and so you have to be aware of it when, especially when you're reading somebody else's code. So I can come here and do my print statement. Let's say age, and I'm going to print it as always. Do this. Let's come down here and run cargo run, and you can see that it is no different. It is an I32 integer that is storing the number 67. In a similar way, we can also just put an underscore here just for clarity so that you're separating the value from the data type. This is also a style that people like, and I tend to like this better than the previous one that I showed you. So if I go and I run, you can see that it doesn't actually change the value. It is just another way of doing your type annotation, and this is called the suffix annotations. Okay, so I'm going to use a comment here, and this is the suffix type annotation. So this is one way. And the last thing I want us to look at is the fact that you can use underscores to make your numbers clearer, okay? Just for reading sake, but internally it is represented as the number without the underscore. So let's say I want to store 10 million, okay? So I'll say let vote count. And by the way, your variable name should be there should be snake case, so you use underscore wherever you would have put a space, because spaces are not allowed. So let's say vote count is equal to 10 million. So I say 10 underscore 123 123. Okay, and this is going to store the value 10 million, even though we put underscores in there. It is just for clarity. When people are reading it, they will see it and they don't have to count the zeros to know what number. And so I'm going to come down here, copy this. Because I'm lazy, I'll paste it here. I'll say vote count, and I'm going to print out the vote count here. So you can see that internally is actually represented as 1 million, and it is without the underscores. So you can see that we have this right here, and in our code we use underscores to make it clear. So this is it about the integer data types out there. Thank you very much for watching, and I'll see you in the next video when we talk about the floating point data types that Rust makes available to us.